Okay, let's take a look at section 2.4, the chain rule. And the chain rule is probably one of the most important rules we have for derivatives. And we really need to take a look at why we need to use it and how we need to recognize when to use it. So I have here just an instance that we need to be aware of, and it's the derivative of a composite function, f of g of x. So what we're going to need to understand is that we're going to be looking at a function that has actually been composed of two separate functions. So think, for instance, let's suppose we had h of x equals the square root of x cubed minus 2. That doesn't look really that out of the ordinary, but it's not really something we've seen yet because it actually is a composition of two different things. It's as if we had one function that was basically the square root of x, and then a separate function that was just x cubed minus 2. And so how did we get to h? Well, really, we just did the composition. We did f of g of x. That would mean us taking that, putting it in there, and that's how we arrive at what we originally showed here. So the goal for today is to actually try and take functions like that and find their derivatives. So here's just generally speaking the chain rule in notation. We have f of g of x, and what we're going to need to do is first take the derivative of what we call the outside function. So we'll say that's f. Apply the proper rule to that, keeping the inside function a part of it, and then multiply by just the derivative of that inside piece. So a lot of times I'll use the phrase take the derivative of the outside times the derivative of the inside. Hard to understand unless we actually go through a couple in practice. So I have three pretty good examples here. Let's take a look at the first one. So very similar to what we just saw, but I don't really like the way that looks because of that squared as well. So I think what we're going to do here is we're going to rewrite that as x squared minus 1, really to the 2/3 power. Now I can see that that is most likely the composition of two things. It's the composition of x squared minus 1 going into x to the 2/3. So this is my outside function, and this is my inside function. So that being said, I could even make this, let's call it f, and we can call that g. So the way this works is take the derivative of y with respect to x. We're going to take the derivative of the outside function, which means we need to apply the power rule. So we would bring that 2/3 down, x, to the 1 less power, so 2/3 minus 1, and that'd be negative 1/3. Now here's what we need to understand though. That was never really a part of it. What was taking the place of x is x squared minus 1. So the first step of the chain rule would be to bring the 2/3 down, rewrite the inside piece, x squared minus 1, and then the new power. But that's only half the story. We then have to multiply that by the derivative of x squared minus 1. So that would be 2x. So if we wanted to see that in a simpler form, we would call it just probably 4x, right, 2 times 2x, over 3, and since that's a negative exponent, we could even put that down here and call that cube root of x squared minus 1. So let's just stay on that problem for a second, because I think what might be helpful for some people is if they actually wrote out here the four functions we're really using, f and f prime, so the outside function and its derivative, and then maybe separate from that, the inside function and its derivative. The only thing we have to watch out for if we're going to do this is we have to understand that the outside function really doesn't use x as its base. It really uses this g of x function as its base. So that's just one example. Let's look at two more, very similar, but now the next one I want to do is a trig example. So now we're asked to find the derivative of the tangent of 5t to the 7th. So first and foremost, common mistake. This is not tangent times 5t to the 7th. See, every trig function has to have an angle. That's its angle. So now, since we don't see that power like we did in the previous problem, the question becomes, well, where do I look for the inside function? Well, again, if the tangent is the outside function, the angle is the inside function. So I'm going to use some of the similar things that we saw in that last problem. Let's suppose we call f of t tangent. That would be the outside function. And let's call g of t 5t to the 7th. That would be the inside function. And let's derive each one of them. So f prime would just be the derivative of tangent, so that would be secant squared. And g prime would be the derivative of 5t to the 7th, and that would be 35t to the 6th. How does that all play into it when we actually go to execute our chain rule? Let's take a look. The derivative of the outside, so the outside was the derivative of tangent, so that's secant squared, but it's not of t, it's of what originally we had in that angle, so that'd be 5t to the 7th. And then simply times the derivative of that, 35t to the 6th. And you're done. Now, may you see it like that? Maybe, but if you're looking at the answers in the back of a book or online, you probably would actually see that expression first, so it wouldn't be uncommon for us to say 35t to the 6th times secant squared 5t to the 7th. I don't think you would see anything different. I don't think you would see this over cosine squared, even though that would be okay. I think that's probably good enough. So it's only two problems, but it pretty much is going to follow that same kind of idea as we go. Now, there are other functions we haven't talked about yet, exponential, log functions, things like that. So right now we're just staying with some of the radical functions and the trig functions. But there's one other thing I wanted to touch upon, and that is the double chain rule. So you say, well, how could we have to do the chain rule twice? Well, let's take a look at what's going on here. First off, again, I'm not going to keep this way. I want to write this differently. So we're going to write this as cotangent of pi t plus 2, all raised to the 2nd power. Why is this going to be double chain rule, and how can I spot this? Well, I have the cotangent very similar to the last problem, so we know that that's the outside function, but then this is the inside function. Well, the problem is then what do I do with that original exponent up there? And the reality is I have two outsides and an inside, or kind of things that are embedded in other pieces. So really, I have an outside function of something squared, and all of this is inside. But when I go to take the derivative of that, that's going to cause me to have to do another chain rule as if it's its own problem. So let's walk through it. So the derivative here is going to involve us taking the 2 down, rewriting this to the 1st power, and then taking the derivative of all of that. So we start with 2 cotangent pi t plus 2 to the 1st times. Now here's the deal. We have to take the derivative of this. Now if you think back to the last problem we did, tangent 5t to the 7th, we're in the same boat, and that problem itself was chain rule. So we have to now act as if this is outside and this is inside. So the way that's going to look, the derivative of cotangent, which is negative cosecant squared, but it's still of pi t plus 2. But then that has to be multiplied, finally, by the derivative of that innermost function, pi t plus 2. And that's just a number times t, right? Plus a constant. Constant goes away. That derivative is just pi. So that's a lot going on right there. So what would we see maybe as our final answer? Well, everything here is being multiplied. So we actually can say negative 2 pi. That takes care of that, that, and that. Cotangent pi t plus 2, and then cosecant squared pi t plus 2. The name of the game here for chain rule is practice. You're really not going to feel comfortable with it until you've seen just so many that you start to recognize a lot of these patterns. And like I said, there are other functions we haven't even discussed yet, but if we keep in mind the outside and the inside idea, I think those, when we get to them, will probably feel the same way. So I hope this lesson on the chain rule has been somewhat helpful.